Buenas tardes a todos. Good night, everybody. Hacemos una breve introducción a esta importante charla de comienzo para el IED del Madrid Design Festival. Como sabéis, la charla de Marjan van Aubel es en inglés. Yo hago una breve introducción en Spanish, justo para enfocar y encuadrar esta nuestra primera IED Talks sobre, en este caso, diseño de producto, un diseño de producto muy especial. Marjan se hace definir como Solar Designer. Nos parece interesante que esta definición engloba una sensibilidad no solo hacia la luz del sol, que evidentemente lo define, sino la tecnología que conlleva captar la luz del sol en los objetos, diría, de uso cotidiano, como puede ser una mesa, un macetero, una lámpara, y quizás nos hace reflexionar sobre la sensibilidad y la tecnología de manera diferente. Sabemos que la tecnología nos rodea en todas partes y tenemos una relación con la tecnología fácil, cómoda, y diría incluso humana, pero aquí la parte tecnológica se nos hace como sensible y diría casi deseable, ¿no? El hecho de transformar esta parte tecnológica en objeto con vida, con interacción, pero una interacción de objetos que cobran vida, es tal vez el sentido más profundo y más interesante de la obra de Marjan. Hay una breve bio y, como se puede ver, tiene un recorrido interesantísimo, formada en Holanda, en la escuela de Delft, luego en la Royal College en el Master Product Design, y de ahí evidentemente una carrera estelar con premios de innovación, proyectos mejora innovación por parte de Wired, de Swarovski, mejor talento en 2015, diseño emergente, en fin. Tenemos de verdad una auténtica suerte en poder traer una persona como él, joven, pero con un recorrido ya marcado y con una proyección interesantísima. Enmarcar este comienzo en el Design Festival es para nosotros muy importante porque, gracias a toda la labor del equipo del IED de Madrid, tanto académico como de los demás departamentos, liderado en este caso el proyecto por Floriana Petrusino, de proyectos culturales, hemos querido un año más marcar en el programa Design Festival la diferencia con actividades, como en este caso los talks, pero luego veréis en el programa muchas otras, desde las exposiciones, las performances y otro tipo de actividad, un workshop inclusive, enseñar a la ciudad y a todos los que se acercan a este festival, que cada vez tiene más peso y más importancia y más proyección, como la escuela como la nuestra está donde tiene que estar, marcando también un sentido más que tendencia en el mundo del diseño, entendido en este caso en todas y cada una de las especialidades, ¿no? Las charlas quizás son el sello de identidad que hemos querido dar, aparte de las demás actividades, con un diseño comprometido, un diseño que tiene en cuenta no solo, como en este caso, la tecnología, la sostenibilidad, sino también una cierta implicación social, una acción, y con esto queremos, como escuela, también indicar este camino como importante para la formación y para la profesión. So it was just an introduction about your work, but also to include this first talk in this edition, second edition of Madrid Design Festival. It's a brand new festival. Last year starts in Madrid. It's happening 1 month festival. I think it's much more longer than any other activity it's important, I think, to fix in a map of the world of design what happened in the Spanish reality. And as a school of design, we are very proud to invite you, Marjan, in these events and these activities, because with your work that mix sensibility, technology, sustainability, and it showed to students, but not only students. Here we have also professional, and as I want to remind you, everybody, that we are now on streaming, and this talk will be possible also to see in another moment in our website and in our platform. So it's quite important for our students and for the design community to share this great example of a new sensibility around design. As I said before, the mix between technology and objects and feelings, and the way we relate ourselves to the world that is around us. So please, we start with Marjan. Thank you very much for everybody, and then we can interact like you're like. Yeah. Thank you very much.
Thank you for coming tonight. I have no idea what you said because I don't speak Spanish. I try to speak it slowly because mostly I talk very fast. I have 95 images to show you, so yeah, I'll just guide you through my process, how I do things. And I thought because we're your students, it's nice to also not show like, okay, I've done this, here it is, end product, but also the process, the collaborations, how important that is, and how you get there. So it's not only the things you see in the magazines or the website, but the process to that. So if you have questions about that, I think it's nice to have like a time for that as well to ask these questions. So maybe explain you this image because like you said, my name is Marjan, and in my work I focus on extreme efficiency, I would like to call it. So I work with solar cells that use the properties of colors to generate electricity. So here, what you see here, those are tiny lab solar cells. Or I develop materials that expand in size, so you use less materials. So you could say I have two fascinations: expanding materials and solar cells. I think the clicker sometimes doesn't work. It works. This is my studio in Amsterdam. I have a studio in Amsterdam. There's a lot of water. It's on a sort of floating building. Welcome, hello. I heard Spanish people are always a bit late, so it's
They are Italian.
Okay, Italian and Spanish. So you see here, this is my studio on this floating building with a lot of architects, graphic designers, which is it's a very nice place. And I like in Amsterdam, you're surrounded by lots of water, and we could swim here in the IED river. This is. I'm not going to use this clicker, I think. It's in my studio. Use some circuit boards. But I also thought maybe it's nice to show you some holiday pictures, because when you're on holiday, you kind of like you see what you're fascinated by. So this is when I'm on holiday. I take this in New York. I take these kind of photos. This is in the Austrian mountains, and if I see solar panels, I always get super enthusiastic. So that's on the photo. This is my first time in Madrid, and I also saw some solar panels here. Not enough. There's some there on the roof. But also, I like to go to volcanic islands or like work see what like how materials form itself and how that reacts to nature. So let me start by that, the materials itself. This is an expanding porcelain. And if you create porcelain, I don't know if you work with ceramics, mostly you fire that twice. You make a body of clay, you put it in the oven, and then it shrinks in the oven. And then you take it out and you glaze it, you put it another time in the oven and then it has the glaze. So I was working in a ceramic work center. I was doing my internship there, and we were looking for a material that you could fire in once. So you don't need 2 fires to put it twice in the kiln, but just in once. So you put the glaze in once. So we were looking for something like that sample, and then a lot of things went wrong, and some of these came out, like kind of like bubbly materials, kind of like a mistake. And when you have a mistake, that's actually when something starts. And if you're able to reproduce your mistake and note it down and be quite scientific about it, you have a starting point to work with. This is a tiny. Is it foaming? Oh, yeah, no. This is it was in the kiln when it was growing. When you see it like a cake, it expands 300%. So it's really like making bread or cake with porcelain. So here it grows and it expands like homemade bread. So basically doing things differently. So add water. No, it's growing. It's a bit fast forwarded because you have it's this 900 degrees. So you need the camera quite far away. And so basically things that you shouldn't do. The people in the ceramic department didn't like me because sometimes you had explosion and stuff. So it is the calcium carbonate in the ceramics that makes the expansion happen. And if you add water, you can kind of control this. So you see kind of it just going off. It's like lava. So this was during my graduation at the Rietveld Academy, where I first studied. I did my BA there. It was in Amsterdam. And I thought, okay, so if you have this material that foams up and stuff, I thought, how big can you go? What is the biggest size you can make? This was the first experiment I ever did with this. So this was at the EKWC, that's the European Ceramic Work Center, and they have very big kilns where you can put a car inside. So you need, basically made a very big cake mold where this material could be on top and could like layer it and expand itself. I'm also going to talk about my mistakes and failures. That's okay, right? Because I think that's important. This didn't come out straight away, because if you make something small, you have it works different than when you make things big, because you have different tensions in the material. It works differently. So this came out, and it was 2 weeks before my graduation, and it came out and broke in thousands or like 100 pieces. So we had to like glue it back and stuff. But what I learned from this was that it's about the temperature to cool it down, because it's a new material. I was the one that was master at it, but I didn't know either, because it was the first time I did something. So it basically worked more as a glass. So I did a lot of residencies after that and really tried to control and form the material more. So you can use it after. I looked in different qualities, so you have how to control the bubbles, how to control the density and like the transparency. Because basically you have a porcelain that's so light that it flows into water. You can see through, and it expands. So I made different objects with it. That's always quite a tricky thing when you're a material designer. You see all the options, but it's then the question of like, what kind of object? What is it used for this? Because you have suddenly all these options. A classic thing is then to make a light, but I thought it was nice to see this kind of lunar moon shape effect, so you can control the lighting. This material had different qualities than, for example, when I did made a big cabinet, because then I wanted to see how big you can go, and here was more like how light and how thin can you make it. So this is how then you think as a material designer. Like I said, I like things that foam up. This started when I was studying at Royal College of Art in London. I did my master there, and we all got an assignment called tell the story about tables through a table. And I thought, okay, that's nice, but how can I get, because I'm thinking from extreme efficiency, how can I get the most out of this table then? So the first thing I did actually was just cut the whole table up, the IKEA table. We all were sponsored by IKEA then, and I cut it up into a lot of sawdust and little chips, and started reconstructing it again. And by doing a lot of material research and thinking from porcelain, what if you add some resin, what if you did this, it also started foaming up. And I was able to make from one table 7 tables. So this was another thing. I was like, okay, I have another material here where I can start building things with it. This is a film where I show another collaboration I did together with James Shaw, together with IED. And I think Jamie will start talking now.
It's about the mixture of these that we used that gave us the perfect recipe, the perfect combination for making our chair.
So like fine particles and a bigger netted combinations, like what we need. So what we do is we add wood chips to resin, a bioresin. We add a bit of water, and that starts a really bizarre foaming reaction.
And this reaction causes the mixture to, is it double or quadruple in size?
3 levels.
3 double. It grows a lot. But the different mixtures make a big difference. You know, we did some tests where it was growing like 600%, but this would be maybe not as strong. So we did a mixture in the end, which didn't grow quite as much as that.
This is fast forward.
And then when you've got your mixture, you just apply it to the mold. It gets a bit crazy, and it's kind of all trying to seep down, seep out of the way, and you've just got to keep on pushing it back up with your hands.
It was really fun to make this chair because every chair is different as well. And it's in the beginning we didn't have it so well considered yet, so how much it expanded. Sometimes when it was very hot, it expanded like crazy. We didn't have control over it, and sometimes we had to wait a very long time. But the idea started was together with IED, which is the American hardwood export company, and they came to the RCA where I was studying then to see what we could do with wood. And there's hardwood, you have different types of wood as well. And the idea was to use the shaving and the leftovers, if you make the legs, to use that for the seat. And what I like here is that you can really see how the shape forms itself actually. So it's really actually in like the back of a school chair would we used, and that's we made the mold with a jig, so it like literally grows onto the mold. You don't need any screws or nails or something. It's really forming itself. And that's what you can see here as well. Yeah, then they have different types of woods. So walnuts make a selection of the browner particles, and then shape that. So we became quite like experts in wood dust and waste. I worked a lot with Jamie Shaw, who's a designer I met at Royal College of Art. And yeah, so I had done research to foaming porcelain, foaming woods, and I then also got interested in foaming stones. So we were invited to go to the island Stromboli, which is kind of where the dot is, like a boat trip from Naples for 5 hours, and you're at this beautiful volcanic island, where you really see how the material, how this whole island is like formed by forces of nature. I showed this little island because it has one solar panel on it. So yeah, we brought tools and stuff, and we were thinking, okay, we're gonna go to this island and we're gonna do material research to foaming stone. We're gonna find the answer. So we start cutting things up and measuring things. We did like trips to the volcano and see. You really see how through the water, the air, and how the stone forms itself. How you see how the elements and the minerals here, are shaped right at that moment. You see that. I guess I have 95 images, right? So, and then we started talking to stone experts and volcanists there as well. And then I brought some sand with me because on volcano, on Stromedy, everything is black. The whole island is black, the beaches are black. And I brought some sand with me to my studio because I had a kiln there and started making. I thought, okay, now I'm going to do the same how I did with the wood and the porcelain. I'm going to make new foaming materials. But it's sometimes you realize, okay, that doesn't work like that really, because you have no idea what this material is. You don't know what minerals there are, and sometimes it also just doesn't work. So we decided to go back to our specialty, and we made more black foaming wood things, because that's actually where we were very good at. We became like experts in that, and learned how, for example, for example, in the beginning we didn't know how much it started foaming because we were adding some dyes on it, and it was liquid, and then you didn't have any control over it because the black or the dark ones start foaming more, and then you thought, okay, what if you use some powder pigments and you can control it more? So it's, by doing a lot of things wrong, you learn and you make mistakes and things. And in terms of the foaming porcelain, I think 90% failed. So you have, you need a lot of perseverance to keep on going, to learn from these mistakes. This is another collaboration I did together with, also at RCA, with Hilda Hellstrom and Ola Mirecki. And we started looking at different techniques from other disciplines. For example, the butcher, how he makes his sausages. He puts it in a case, and we started mixing jasmonite, which is a material that's is kind of between plaster and stone, so it's very hard. And we started adding that into the sausage casing, and it became quite a weird material where we started making things with. So 3 girls went to Berlin to make a project about sausages. So there was, we made like different meat bowling, you could did little games, and it was a lot of fun and experience, and it was nice. It was kind of the start for all our projects, for our graduation projects here. This is another project I would like to just show, is how that started, because it started with an idea of also a fascination of the idea of like flying, what you do, how to fly. So I made these sky glasses because I learned that the feeling of flying is you're kind of like in another dimension. You're not on the ground, but you also have this idea of the Z thing. So you're disorientated. I put a little camera on a bird first to see what you would see if you would fly, and I did. For example, I went indoor skydiving to see the feeling, and you basically don't know what's happening. And then I invited someone from the Cloud Appreciation Society. I lived in London, and in the UK everyone has clubs to appreciate something. So there's also a Cloud Appreciation Society, so someone that looks into the clouds. So we invited him, and he gave us a little tour.
see the cumulus clouds are more, the cloud is more joined up into a layer. Now it's not a layer that is completely flat and featureless. You can see on the base of the cloud that there's some difference in tonality, from darker bits to slightly lighter bits, greys to whites, and that is what you would not, that's what's described as a stratocumulus cloud, and it's really like, it's composed of individual cumulus clouds that are joined together to form a layer. And you often find cumulus clouds through the day will start to join up to form into a stratocumulus, or perhaps what starts as a stratocumulus will break up, it's a bit more what we got today, will break up into more individual cumulus clouds.
Because if you wear it, you don't see where you walk and you just see the sky, so you're literally with your head in the sky, with your feet are kind of on the ground, but you don't know where. I should have brought some, you would have tried it here. It's nice with the trees, because then you don't see where it is. So then, I started going up again already a bit more to the sky, because I kind of want to talk about my real fascination, which is the sun, and what you can do with that. I have another short film to see will explain the power of the sun as well.
Honestly, you do not want to be here right now. It is the hottest I have ever felt in London. It's all because of that building beside me. Jim Watterson is a reporter on Sydney AM. He's just cooking up some lunch here. I can't even lift it up, it's actually that hot. He's just fried an egg here on the streets of London. He's just putting that in there for his story. It is so hot. It is so hot. There you go. He has just cooked that egg on a frying pan on the streets of London. If you just look back down there, cameraman Jim, those tiles have just popped off in the heat. That's how hot it is. It is like being under a magnifying glass, and we need to get into the shade actually. We have with us a solar physicist who is Dr. Simon Foster. If we can just kind of squeeze this street in London is rapidly becoming a tourist place.
It's ridiculous. Look, they've come dressed for it. But it's focused down here. The building behind us is focused down. I've never felt heat like this. I stupidly left my bag out. And you probably see, so this is actually, it got up to 92.6 degrees.
That's Celsius.
That's Celsius. So that's how hot, as I say, I left one of my boxes out that actually contain this. And that's how hot you get. You can't believe how hot it is. It's actually really unpleasant to actually be out there.
You're a solar physicist. Just explain this to us, because I've never felt like this in London.
So basically, it's like a satellite dish. When you've got a satellite dish, it converges or forces radio waves down onto a point, and then you put your transceiver, which you receive them. Now you can do the same with light, and that's what this building is doing. Basically, you've got a vast area that's collecting sunlight, and it's focusing it down onto a tiny point, which is where we're standing. So all that sunlight that's hitting that building is being focused down here. It's like being under a magnifying glass. You know when you can burn stuff. That's what we're in. It's like a giant version of that, and we're feeling the effects. It's really deeply unpleasant.
What I like about it is saying these buildings are constantly there, you know, and we can walk around and we can move away from this heat because it's about the heat. But yeah, these buildings keep on going there, keep on receiving the sunlight the whole time. And if you think about the fact that 1 hour received enough sunlight to provide the whole world with enough electricity for an entire year, and then you think how we don't see so much solar panels yet, then I really think there's a lot of work to do here. And I mean, the sun is still available for everyone. It's free and available. We can especially here in Madrid, even in winter here, it's plenty of it. So yeah, let's talk about solar cells. Because solar cells are invented in I think 1883, and they were 1%. And since the 1950s, they started reproducing them. So this is a commercial from 1958. It was the same year that the first satellites went into space, the Vanguard. And since then, scientists all over the world have been working on their applications. So this is, for example, a phone call, the first phone call made by solar panels. This was as you can see, in the 80s. This is, if you Google solar design, you get things like this in the Disney World. Or in China, the shape of a panda in solar panels. Yeah, so since the development, scientists have been working on reducing the price of a solar cell because it was very, like I said, it was made of gold, super expensive, but the prices dropped enormously, and that's because China is producing them on a very large scale. So yeah, the prices dropped, and also the efficiency has increased a lot. From this 1%, now solar cells even have an efficiency of 40%, which is huge, massive. But if we think about the image of solar panels, it's kind of stayed the same for the last 60 years. It is still this technology just stacked onto something and not very integrated into its environment. You see here, like, when I went on my holiday here. So I think I really see a need of design here, and we can't wait around for the engineers or the government to make changes and say, oh, we all should have solar panels. But we all can make changes. Like I said, I'm a designer, and I would like to change things through design. And I see a need, and that's also why I started focusing on solar design. I just did that and forget about the materials now because there's a massive need for that at the moment. Let me give you some examples of my work, how I do that and how I integrate these things. I collaborate, for example, with Swarovski, which is the crystal company. And if you cut crystals in a certain way, you're able to bend and direct the light onto a certain point. So I use these to focus the light onto a solar panel, making them more efficient, as you can see here. And this work is called cyanometer. And these, you can basically take the solar panel, bring it into the light, because it's portable, put it in a docking station, and then it's powering these chandeliers. So you're literally taking the light, the sky indoors. And it was part of the Designer of the Future Award. And then you're invited to Buttons because they have the crystal factories in Austria in the middle of the mountains on a super beautiful Tyrol place. And if you think about crystals, you think about this kind of these shiny things, but this is also a crystal, and it has if you shine light through it, it has the same refraction as the sky does. Because if the sun goes under, it changes and goes to this red light. So that's why the name cyanometer. That was a tool to measure the blueness of the sky. So I really enjoyed working with Swarovski because you could really use the material, the glass, as material and see how much you could get out of that. And eventually making solar cells more efficient because you use it as a lens. So this was in Basel with Design of the Future. It was Jimenez who made the architecture, and Satoshi, he made 3D crystal, 3D printed crystal. So we had a show together and worked also together on how to make that. And I was giving light to the chandeliers. But I'm going to show you a bit why the films don't work. That's a shame. Because I really got hooked onto solar when I saw this technology, and it's called the dye-sensitized solar cells. And they're invented by Michael Gratzel in Switzerland, and he basically started his research when he was looking at photosynthesis, where you have the green chlorophyll that converts light into sugar for the plants. These cells convert light into electricity. And I was really looking at that process. I was able to imitate that, and he first started that with basically with blueberry juice, because it has so you have different types of different colors have different efficiencies. So, for example, red is more efficient than yellow, for example, because different type, different place in the color spectrum. So he has been developing this, and since then companies and labs all over the world started working with this technology. So when I heard this as a designer, so a colored glass surface that's able to harvest electricity, that's able to produce energy, and it also works indoors because it's so sensitive to light, I just thought, okay, where can you apply this then? This is where I started the energy collection. And it's basically a glassware where each cup and each plate has these integrated solar cells. So when you don't use your cup or plate, you put it in this cabinet, which you normally do, and the cabinet then stores the energy that the glassware has collected. So you can see a circuit there. And through the batteries on the side, you can charge your phone or a light. So basically this cabinet becomes a big battery of the lights in your room. Well, the more energy, the more surface you have, the more energy you can harvest. So I start looking in your room, like what's a lot of surface that you don't use, which is, for example, a table. And this is a current table where the whole tabletop consists out of these sensitized solar cells. So in the side there's an integrated battery where you can, through USB port, charge your phone from. And here you see these orange lines are the solar cells. And this is all the time thinking about this balance between efficiency and aesthetics. For example, the table is orange because it's a very stable color for indoors, and so that's why the table is orange. And it has a certain pattern to explain, okay, there's like electricity going through, it's about electrons and photosynthesis, so the leaf pattern as well. This is always the most asked question I get is, okay, so great, but how many phones can I charge from this then? And then I go into this complicated answer of like, well, it depends where the table is. Is it next to the window? Is your table cleared? Is there a lot of stuff on it? So the table has now integrated sensors that reads the light intensity of the room. So through an app, you can just follow how much light the table is receiving and how full the battery is. So you understand, okay, in July the table works better than, for example, January, or I have to put the table next to the window, for example. So I didn't do this alone. I worked together with instrument product development and Chem too. So because it's easy to make a prototype. But if you think about like how to make it on a larger scale and what kind of production methods you use, you need to work and collaborate with different parties as well. So this was during our launch at the Victoria and Albert Museum, where we for the first time showed the table. This is in a gallery in London as well, where we replaced all windows with current windows, which is a modern version of stained glass. So here you see the colors, the colored windows, where people from the street could come and charge their phone from, so it's from outside and indoors. So really giving extra functions to objects. The window doesn't have to be just the window anymore, but it can also function as a little power station. Just really think of like how to integrate aesthetics into functionality. And the thing is, I'm talking here now about how much I love solar, but I don't have solar panels on my roof. So I live in the center of Amsterdam. It's a monument, so I'm not allowed, and it's not my own house, so I can't have solar. Yeah, I don't have access to solar. I have just a couple of these garden lights that only work in summer. But so then when I started thinking, how can we make solar more accessible for everyone, for a bigger audience, and how can we integrate it more into our cities and our environment, and where you can also really use it right at that moment. So I'm gonna show you a little film here. Her voice is much nicer than mine.
The world's population is growing, and so is the demand for food production. New technologies make controlled farming more efficient, but require a lot of energy. Every hour we receive enough sunlight to provide the world with enough electricity for an entire year. What if we could tackle both our world's energy and food problem? What if we can grow using the power of the sun, but more efficiently using high-tech farming? The power plant is a self-powering greenhouse. Through a transparent solar glass, it powers its indoor climate. We are now able to grow food in places where this wasn't possible before, such as rooftops or places without access to electricity. We need to rethink the future of farming. Through solar design, solar technology can be integrated much better into our environment. We believe in a positive future with the power of design. We want to make a difference by growing the plants of the future.
This started really when I was in the train driving to the Westland, in the area with all the Netherlands with all the greenhouses, and I was thinking about the solar glass and thought, what if you can include all those greenhouses with transparent solar glass, because that is actually where we really need that. So it really started as a question. I created a small team consisting out of engineers and architects. And we joined a competition called the Climate Action Challenge from What Design Can Do. And we started researching, is this even possible? Is this, how can we make this happen if it could really work? So we started working with universities that were specialized in the light and plant growth, and working with companies such as Philips. And again, it was a journey, like a research journey of bringing all these parties together and see, just a simple question, is this possible? Because the solar cells need light, the plants need light, would that block, would that interfere with each other? And even like, does the industry want this? Talking to a lot of farmers in the Netherlands, and some said it's a very nice idea, but if we have like 1% less sunlight, it means 1% less profit. So it's a slow industry to change. So think about it, okay, we're gonna change all the greenhouses now. You need to start quite small, and also on the place where it actually makes sense, and where design also makes sense, and where we need this electricity. And if you think that more and more people come and live in big cities, it makes sense to also start this into the city. So the idea was also, for example, like, what if you could make a sort of, I went to the Crystal Palace here in Madrid. What if you can make sort of a new 21st century version of that, where you can really see with all these new technologies how we grow the plants in the future, and how would that work? But another idea, I'll just talk through it. This is the first prototype, where we use this transparent solar glass. You can see the solar cells are in the sides, so basically you don't see it. And that was, I think, the biggest compliment I got, were the solar panels. And I think that's when design really works, when you don't see it anymore, when you don't see it as a technology that is stacked onto something, or not, for example, our clothes, that also started as a technology, but it's been considered and really like thought through and designed and designed and designed. so it becomes part of our nature, and we don't think about it anymore. So here we built this hydroponic system. Maybe I can explain what hydroponic is. It's you pump around nutrified water, and so you can basically say, okay, I want my tomato to taste like this and this. You can just add your data, okay, I want my tomato to taste as in the southern part of Italy, for example. With data you can recreate that environment, changing the heat, the nutritions, and you pump around that same water. You also save 90% of water usage because it's just a closed system, so it keeps on coming from the same place. And also these colored LED lights. A lot of researchers are researching that you don't need the full spectrum of sunlight. Some plants need only red light because that's for plant growth, and blue light is for that the fruits are or the flowers are ripening. So you can really control and see, okay, I want my plants to be like this, to grow like that, and to taste like this. And for this year's design biennial in London, I was representing the Netherlands in a little pavilion. So you could build a tiny power plant here, where you can really come in and really feel and see how this future could look like. So you could hear the pumps going and control the lights and smell the plants. And I think I could have written a report about a lot of research, but I think it's important. That's why also kind of like the power of design is to really build it and experience it. And then I invited also at the Dutch Design Week some farmers and some scientists to talk about this and to bring people together as well. So it's really making bridges and linking industries. It's also nice to work with a lot of people and to build this and to test this thing. We had students from the University of Amsterdam that were into plant physiology, and some were studying physics. It's a light calculation to see how that works. I thought it was also nice to maybe talk about something that isn't finished and what I'm working on now. Because I'm collaborating now with the Dutch ECN, that stands for Energy Center of the Netherlands, and they are a solar research center. So I was able to work as a designer, solar designer, together with more fundamental solar research, and to see, can I change I can't change the physics of the solar cell because it has this certain way of doing it, and that's been proven that's how it works best, and you can test it. But it is interesting to see can you make little changes, and how can you, for example, make solar cells portable, or can you change things, the physics a bit that it works indoors or near the window. So this is a center next to the sea in the Netherlands, and I'm looking at different solar panels, also more traditional solar panels, because like I said in the beginning, the price of solar has dropped, so you don't need a tiny little place on the roof anymore, but you could have the whole roof, for example, and there's much more space to experiment that. So think about putting layers on top of solar cells, or looking at filters, how to direct the light. Because if you put a glass panel over a solar cell and you see reflection, it means you have less light on the thing because it reflects it. So these are things you could design and think about. And I don't have any images of it yet because that's where I'm here. But I thought it was nice to show you what I'm working on now. So this is a way of printing onto solar panels. So you have different techniques. So you can create patterns onto glass, but it doesn't affect the efficiency that much, and also it doesn't matter so much because you can now put it on places where you wouldn't put it before on. For example, like the buildings or the floors or whatever. So this is where I am now, and kind of like on a mission, I would say, that is to really think, what if we can integrate solar on like that solar becomes a much more natural part of our daily environment, that you don't have only like the windows, but say the curtains, the roofs, the floors, that everything becomes self-sufficient, but then in a much more considered and much more designed way. And I think that's also what I would like to share with you, and we can think of how to do that together. So that's why I say I believe in a solar democracy. Thank you.
Any questions? I have a question to start. You start your research with something much more material, rough materials, and now you turn with something that you can touch or only feel like light. Do you think that it's possible to come back and turn this sort of immateriality through objects or through things that you started with something much more technical?
Yeah, sometimes it's frustrating that the more advanced you get, I can't make it myself anymore. That sometimes I have to work with labs now, for example. But it is still nice. So, for example, the image I showed you, working with filters and to kind of like manipulating the light. It's also a material in the same way. So, is it yes and no? You have to find ways of working within this material. I can't change the layers of how the solar panels are made, but still the surrounding of it I can change. Does that make sense? I hope I talked a bit like, because that was the aim of how to get to this collaboration and how to work together with, for example, an institution like the ICN, and that it's never me, the designer myself, but always in collaboration with the lab or with the timber factory, for example, with the chairs. That is very important also to, and as a student, you're in the best position to do that, because companies and institutions are very open to you then, and you have very easy access for collaborations.
At some point when you were thinking about this solar design, you have to collaborate with other brands. At some point with the labs, for example, they say to you that your idea was impossible to make it real.
Yeah.
How was that challenge for you to make it happen?
Yeah, that's you always and especially scientists, they have a special way of doing things. It's like they think about an end result and the quickest way to get there. And if you, as a designer, you sometimes don't know what you're going to make, and you have to try things. And you get a lot of at the beginning. You get a lot of no's. That's not possible. That's not going to work. Why would you have indoor solar panels? Because the sun is outside. But by just pushing it and saying, "Is it possible? Is it possible?" Suddenly you see, okay, you could try it, and then you can work together. You have to be persistent.
You know that I am really interested in your project because I think that you are more than a designer. You are like an inventor, no? Who experiments like any other scientist. So, according to you, which are new skills that designers have they need to have for the future? Maybe should they integrate more technology or science in their work?
I think it's definitely, for example, good to have a sort of basic knowledge about things, like learn how to program and how to work with Arduino, but I think the skills also of designers to not know, and to make, like I said in the beginning, to make a mistake, and me going to the ceramic department and do everything wrong. If I would have learned ceramic first, I think I might have not done it this way. So it's kind of keeping this open vision and keeping able to make links that didn't exist before. I think it's difficult to learn it, but I think it's an awareness you need to have. And if you know how to program, you won't change things anymore. But yeah, so it's a balance, I think. Because you need to have certain skills also to make things.
Do you ever have any contract with the big energy companies? Because you talk about solar democracy, and we believe in that. The big companies that manage all energy.
They kind of like would be against it, of course. They like, I spoke to Shell, and there's a Dutch Eneco Energy. They like, yeah, it's a weird question actually, because yeah, I'm basically saying no to them, which is because yeah, then you're for the same thing. If you would put a lot of solar panels into the sea, for example, you're still putting the power again with the big companies. If we now have the opportunity to create energy at a place you directly need it, you're independent and you don't need these companies. So it's yeah, double.
I have, which is not exactly a question, it's curiosity. Because when you were talking about the problem of putting solar panel on the roof, also in my city we can put solar panel in the city center because it ruined the landscape, historical landscape. And 1 year ago I read an article about Tesla, you know, the car company, who was developing I don't know how it called it, the block you put on the roof.
Solar roof tiles. Yeah.
And which are made of solar panels. But every few months, we heard nothing. It's like a project failed because maybe it was not enough efficiency. It was just a curiosity because you remind me of these articles which I wrote.
I think what they or Tesla did is also to introduce that with like a lot of publicity and say, okay, this is coming, and then you need to raise funding, and then you need a couple of, I guess, years to develop it and to bring it out on a big scale again. So I think it was like a publicity stunt, and now they're developing this solar tiles, because what it is when you're, I think if you look up from the sky, you see all the solar panels. There's a very clever way of also directing the light. When you look up, you think it looks like solar, like just a normal roof tile. So it's a very clever design. And I think now they're in the development phase, and it takes time, testing and stuff, but you just saw renders, and like this is coming in a couple of years. The same with the cars. So you have like the first electrical cars, very expensive, and then making it in steps, ready for the market, so it becomes affordable. That's how the market works, I think.
And for you, which is the most important barrier or obstacle in order to have a real solar democracy? I mean, governments, prices, or just people's awareness about solar energy?
You ask what the biggest obstacle is?
Yes, like a barrier. I mean,
well, I think it's
or company also that want to invest.
It's like basically the same answer as the Tesla thing. When you come with new invention or technologies, it's always very expensive and it's not ready for the market or the public. And then you need to produce on a bigger scale, and then it becomes affordable. But you always have to have the first people that do this crazy thing, and people think that's crazy. But now, for example, IKEA has not worldwide, but in a lot of countries they sell solar panels now. So now I also spoke to IKEA, for example, and then that takes time and stages to go through. So the barriers are, I guess, time and the resources you have at the moment.
Questions? Okay. Well, thank you very much for coming. And I just want to say again that we are part of the festival, Madrid
Madrid Design Festival. Thank you, Alvaro and Teresa, for coming. And we start with this festival, with your lecture, with your talk today. As you can see in the program, we are full of activity, as I told you at the beginning. And we are very proud to start with you because, as we told at the beginning, it's a mix between design and technology. We finished with something really powerful, as we can see, the level of your research opened new fields of investigation, of research about light and design. And as my question at the beginning was like how you evolved with this rough materials to something so intangible, but in reality it's not so intangible because you turn it into something that we can feel about. So thank you very much. Thank you for coming here in Madrid. Please take advantage of the Madrid Design Festival. There's a very powerful program, not only here in the IED Madrid. And thank you everybody for coming. Also Simone and Elena from the Italian Embassy and all the people here